All right. Hi, everyone. Thank you for joining us for our webinar titled AI Detection and Response. We're happy that you're here. Before we jump in, I just have a few housekeeping items I want to run through with you all. So there are several tabs underneath the viewer screen, so be sure to check those out. All of you are also currently in listen only mode, so we won't be able to hear you as we're going through this presentation. But if you do have any questions, you can go ahead and please submit your questions in the Ask a Question tab, and we will do our best to answer as many as possible during, but certainly if we don't get to your question, we'll be able to address after the presentation. Additionally, so the on-demand version of this webinar will be available following the session. It will be sent to you via email as well as available on our website as an on-demand viewing. So that's it for housekeeping. I am really excited to turn this over to Russ Elsner. He is the VP of Product Management, and he will be walking through AI detection and response today. Hi, Russ.
Thanks, Ellie. And thank you, everybody, for joining me today. I want to walk through the AI detection and response product, talk about both how we see ourselves in the industry and also where we see this product in this industry moving forward. Taking a step back, sort of what is BigPanda known for? We focused a lot of our energy sort of historically on the event management and basically helping organizations streamline their L1 response. We focus on faster detection, faster assignment, faster workload, reduced workload. So really to make the whole process more efficient and faster and get organizations more reliable service. So we do that through hooking up to any type of observability signal, cleaning, normalizing, correlating, and then automating a lot of those workflows. We've had a great amount of success with that, and a lot of our customers have had really phenomenal results from using us. However, if you take a step back, enterprises are still spending around $200 billion on L1 operations. And if we actually have to be honest with ourselves, L1 operations is not all that good. It's error prone, it's slow, it's very human capital driven, lots of humans, lots of people on this, and the results are only moderate. If you think about what an L1 operations has to do from a manual standpoint, there's just an enormous number of different tasks that people have to execute, right? Something detects a signal, whether it's an observability tool or maybe it comes into the service desk. Teams have to acknowledge them. They may have to execute run books. They have to pull data from observability tools and do some basic investigation. They have to update ticket notes. They have to decide whether they can resolve the problem themselves or escalate it to another team. They have to then send it to the team that may get re-escalated or redirected. So there's a lot of just manual energy that goes into this. And this is happening day to day by thousands and thousands of times across, across many, many different organizations. And really what it means is that, frankly, L1 as an industry right now is fairly inaccurate, low detection rates, erroneous escalations. It's fairly slow. There's SLAs. We hear 15-minute SLAs to deal with all inbound tickets. It's very frequent that those don't get met. We know that we have disappointed customers, and we know that as an organization, right? You guys as L1 operators, have redundant investigations, needless interruptions, and so how do we make this better? So fundamentally, that's what we're looking to do: is how do we make this process better for the industry? And I want to walk you through the way that we are addressing this. So the product we're talking about is called AI detection and response, and we think of it as really having four components to it. And if you actually think about it, those map to the components I showed on the last slide. There's a detection phase, right? Somebody has to detect that the real problem is going on. That might come from observability, it might come from service desk, it may come from some other signal, right? But how do we know what needs to be addressed? The team needs to then diagnose it. They need to then triage that, and then they ultimately need to figure out how to respond. So each of these different phases has different steps that currently humans have to do, and we think there's a better way. AI detection and response is built on top of what we call our IT knowledge graph, and that's a very powerful set of data that is indexed and normalized and built and has your operational knowledge built in. So it has access to prior tickets, prior incidents, change. It can have access to obviously your observability tools. It has run books and possibly SOPs and knowledge base articles and other informal knowledge. It has this wealth of institutional knowledge that we can use AI now to help automate many of the steps that humans go through. So if you think about each one of these steps and you think about, what is BigPanda known for? What do we have that we've been working on and providing our customers to this point? And it's really detection within, classic event management. We have diagnosis where we do root cause investigation for possible changes. This change maybe caused this. Looking at historical incidents within the realm of what BigPanda has seen in the past. Triage with things like priority assessment, root cause assessment, and we can then obviously automate things by sending, by attaching to your ticketing system or kicking off workflows. So that's what we're known for today. And I want to talk about is some things that we've announced recently that we're really excited about that we're building into the product as we speak. So the latest product announcements that we've been talking about are the four that are in blue right now, and they really feed into this detection and diagnosis category. And so we'll talk about each one of these in a little bit more depth today. But within detection, we want to talk about two new forms of detection that add new signals from the service desk and from the external surface, right? So outside of your four walls. Within diagnosis, we want to talk about a new form, a really exciting form of AI-based correlation that's going to dramatically change how efficient operations can be. And we're going to talk about agentic runbook automation. And all of these collectively are a huge part in further automating the L1 process. So going from that very human-driven, very manual step-by-step process into a far more agentic and automated future, and taking a dramatic slice of that 200 billion that people are paying for manual L1, seeing how much of that we can reduce. So if you think about the typical workflow today, what you wind up is you wind up getting an incident, right? So you have a bunch of alerts that have been cleaned and aggregated and brought together, and so there's a body of knowledge about the firewall incident, and the human takes that, and they now need to figure out what to do. And we saw all those steps in that prior slide. When we talk about automating L1, what we want to do is we want to automate the next concentric set of decisions or tasks that the human has to do. So for example, for a typical inbound firewall incident, it's very likely some run book that tells the human what they're supposed to do to investigate, diagnose, and then ultimately potentially respond to it. Well, we can find that, make that run book association agentically, and then we can start executing the stages that the human would do. Those stages might result in a bunch of diagnostic screenshots, reports, validation within tools, verification. So we can do that type of stuff automatically, and that information gives us context in attached to things like knowledge base articles for the firewall or for services that use the firewall, historic incidents that are very similar to this in the past. This has happened 8 times in the past. How have we dealt with it then? Changes that are correlated. We can then also correlate in other active incidents. So while this firewall incident is active, there's simultaneously a network incident and a cloud incident, and there's a very high likelihood that those things are related. So again, additional context to the operator. Those incidents can have runbooks that are executed that provide additional diagnostic information. So the idea is all of these things are run automatically, contextually, so that the human can take this information, including external events and service desk tickets, and this is the detection and diagnosis piece where we've done this automatically and agentically, and we can feed that into a triage service that can again help you with impact assessment, priority assessment, root cause assessment, and suggested next actions. At that point, the human is given options on what they can do next, and they will then either accept those and take those actions or take additional steps. So I want to go through each one of those individually. So let's talk about, first of all, agentic runbook automation. And I talked about this a little bit earlier, but really what this is the ability to take AI and have AI detect, discover the runbooks associated with particular active incidents and start to execute them. So lots of investigation runbooks are things like log into Grafana and look at the CPU utilization, go to this particular tool, maybe it's Datadog, and pull logs from that tool, check if there's a memory pressure on that particular service, check if any changes have been made. So it's a bunch of steps that a human will go through and mechanically execute, and there's really no reason that an agent can't do that for them. So agentic runbook automation is exactly that. It's having a BigPanda agent that will find and mine that runbook and then start executing the pieces that it can do automatically for the human and start putting that data together and reason across that logic in that runbook and automate as many of those steps as possible. So I have a screenshot, for example, where we've had an incident. That incident was automatically associated with an existing runbook that your teams are already using. The agent has parsed that and has figured out what the various steps are in the reasoning steps and started executing those. So the first thing it did was it went through and did a CPU check. And it found the CPU was in fact higher than the expected threshold. It went through and got logs from Datadog in this particular case, and it attached those into the incident itself. It then did a memory check and it looked for recent changes, and it found out that there was no memory pressure and there were no recent changes. So it's basing its recommendation on the CPU and the logs. Simultaneously, and in fact, in parallel, it's gone back through the history of incidents that have happened over the last 6 months, 12 months. It's found examples where this incident has happened in the past and has looked at the outcome. Who was it assigned to? What was the priority? And what was the resolution to that? And it's mining that data as well. And all of that is going into a recommendation in which the AI is making specific suggestions. It's saying that in this particular case, the incident should be set to P2 and it should be assigned to the SRE team. And in fact, you should create a JIRA ticket for that SRE team, with fields populated. At this point, the human hasn't had to do anything. The agent has done all of this work for it. All the logic, reasoning, data that was acquired is further down in this ticket. So the human can review how it got to these decisions. And the human can decide if this is ultimately what they think they agree this is the right thing to do. They hit apply all, and that work gets done. It's set to P2, it's assigned to the SRE team, and a JIRA ticket gets created with all the relevant fields filled in. So if you think about what would a human have to do prior to this, lots of manual steps, lots of work, lots of things. And now all of a sudden the human is in charge of approving the decision that the AI has made. So we think this is an amazingly powerful technology. We think this is going to revolutionize how L1 operates. We think there's a massive amount of savings we can get through taking advantage of AI to automate manual tasks, leaving the humans to do the important things like assess and then ultimately commit those changes. So you could then ask yourself, okay, well, wait a second. What if the runbook doesn't have sufficient context or doesn't provide sufficient context to automate all that? We have another really exciting feature that leans heavily into AI, which we think is going to be tremendous in terms of the efficiency of L1 and the efficiency of the overall operations team. And this is about incident correlation. So when we think about incidents, really incidents are groups of alerts that have already been cleaned and normalized and correlated that are similar. And so a lot of our customers like to have a network ticket or network incident that creates a network ticket for the network team to work in a server ticket and maybe a storage ticket and a firewall ticket. And so they tend to want the tickets to be team related, but we all know that those technology stacks don't fail in isolation. They very frequently have cascading effects, cause and effect on each other. It is very, very typical that multiple incidents may be going on simultaneously that are related to the outage that you're seeing right now. And that's what incident correlation is doing, is it's using AI, it's mining that knowledge graph, the IT knowledge graph that we talked about that has access to things like run books and knowledge base articles and service topology and all of this institutional knowledge that's honestly sitting in the brains or in systems in your organization, but it lets the AI mine that to create this additional layer of correlation where it's doing incident to incident correlation. So in this particular example, I'll show you a screenshot in a couple seconds, but this is really a simplified version where we're using there is an active application incident happening right now, and there are dozens of other active incidents happening in the enterprise. But what's happened is the engine here has specifically picked 3 that it thinks are highly related to what's going on with the application. it leveraged or took advantage of service topology that has access to correlate the firewall incident to this application incident. It took other clues or breadcrumbs within the knowledge base, for example, a KB article, to associate the active cloud incident, which it thinks is also related to this application. And further all, it then took change records that has access to and has been able to relate those, the application incident, to a network incident. So of the several dozen incidents you might have going on, these four seem very, very highly related, and the root cause is within those. This is actually a screenshot of a version of this in which we're actually doing this on live data. And what you see here is that there's actually a multiple layers of relationships. If you remember, each one of these bubbles is itself an incident which has a whole set of correlated alerts in it. And we're now, in this case, correlating 7 of those incidents together. And you can see that some of them, we have the primary, which is sort of the heart one, the one that we're trying to investigate. And we can actually see other incidents that are related either through a common cause, meaning both of these seem to be caused by something else, or A causes B. In fact, if one, A causes B, you would see a red line there. So again, another form of very, very powerful AI-based correlation where there's no human rule writing, the humans don't have to understand these relationships ahead of time. This is the AI finding these relationships in real time based on mining that operational knowledge that it has about your organization. An incredibly powerful capability that I've actually been trying to spend the last 20 years of my life trying to solve this particular problem, and the power of the data, the new types of data access and data collection that are available, and the new types of AI that are available have really, I think, cracked the code on this one. So it's something that we are amazingly excited about and would love to talk to you about further. So there's another issue with, if we're talking about, automating L1, right? Getting L1 to be more efficient and automating that. We already talked a little bit about the fact that maybe not everything comes in through observability. Not everything's being a machine-driven event from observability, but there are other ways that signals come into your organization stating there's a problem. And what we want to do is we want to expand that surface area as well. So in fact, if you think about it, and your organization may vary a little bit, but this seems fairly common among organizations, that observability tends to catch about 40%, 50% of the inbound incidents, but a huge body of them also come from humans calling into the service desk. I can't access this application. This is slow. This is broken. Whether it's your own employees or maybe even your customers calling in reporting things, that's another signal that operations really needs to be aware of. There's also signals that come both triggering signals and correlating signals that come in from outside that we also want to be able to make uh, our customers aware of. And so what this is basically creating two new parallel data pipelines to our event management pipeline, event management being the top one that's driven by machine data from observability tools. The service desk is being driven by humans filing service desk tickets to the service desk, and we're taking that data as a new stream of visibility to know if and when something's going on. And then the third one is data from outside your four walls, whether it's from internet providers or ISPs or power or utility or weather or down detector tools like that. But both of these new signals coming through, and us, again, through AI, doing anomaly detection. So detecting signals operations needs to know about and providing them visibility to things they would otherwise have missed, or correlating signals into the ones that are already known about. And so we have that both for service desk observability. So this is human tickets come in, we're classifying the ones that are important to current signals, we're filtering them, enriching them, and then sending them through that AI detection engine and correlation engine. And that gives you now the ability to understand where there are active signals coming into part of your organization, the service desk, that are important and business impacting enough that the operations team should know about them as early as possible. The other one, the external observability, is looking at taking advantage of all the data that lives outside your four walls, that almost all of our services that we build today are not just confined to our own center. We use external third-party SaaSes, we use cloud providers, We rely on network and ISP coverage to get to our customers or to our branch offices. There's all sorts of tertiary dependencies with things like power and weather, and all of these things could ultimately affect our services. And these signals are readily available if you know where to look. And so another thing that we've added into our platform is the ability to BigPanda gathers this huge surface area of public observability data and brings it into our platform, and then we'll help correlate those types of that data into the incidents that you're experiencing. So, an example might be if you're a gaming company and you something goes wrong and users can't log into their game server. A lot of times they complain on social media, whether it's on Twitter or on Reddit. The idea is tools like Down Detector can be monitoring that and then can funnel that as notification into BigPanda so that your operations team, even though an observability signal didn't come in, you're getting signals from outside saying your users are unhappy. That could also come from things like, you have a restaurant who's very dependent on something like an Uber Eats, right? It's a big part of its business. Well, if Uber Eats is suffering an outage, can you be made aware of that? The third example I'd give is that imagine you do have, you're a bank branch or you're a restaurant, you have remote sites, and you lose connectivity to one of your sites, or the equipment goes down in one of those sites. And so, is it a networking problem? Is it an equipment problem? Did something happen with maybe there was a network outage, or maybe somebody pushed a bad change? But you may also find out that it's just a power outage, that location that region is in is right now in a local power outage. And so by marrying that piece of data, correlating that into your incident, it gives your operators immediate context to something they would otherwise spend time chasing after, when it might be something as simple as, hey, the power is out at that location. So let's go back and piece all these things together, right? So we talked about this, ultimately automating as many of those manual steps of L1, and how do we both increase the surface area of the things they're aware of and automate the steps that they do. And this, I'm going to replay this animation that we started with, and hopefully, the first time you saw this, you might have said, "Hey, that's a little bit." Sounds a little bit like science fiction. How are you guys going to do that? And hopefully during the course of today, I've actually shown step by step how each one of those pieces comes in and adds the piece. So we very much talked about the idea of automatically, agentically associating a run book with an incident and starting to kick off the troubleshooting steps or the investigative steps within that run book. So the agent will start doing this automatically as soon as that incident comes in, and that will create a bunch of diagnostic results. It might be evidence of what the problem is, but it might be evidence of things that aren't happening. This evidence is attached into the incident, so both your operators and your downstream people, if this gets escalated, will have access to all this real-time diagnostic information. We've also correlated possible changes, that this change seems highly related to this particular incident, or knowledge base articles where we know that this particular incident is part of a service as a KB article, or the historic incidents about that particular similar examples of this happening in the past. Each one of this gives us a huge amount of additional context about what to do next, what recommendations the agent can make automatically. That lets us correlate in other active incidents to know that, hey, not only is there a firewall incident, but there's a high likelihood that this network incident is related and this cloud incident is related. And those also have diagnostic information that is attached into the ticket. So again, more context and more information that was automatically attached to this particular incident. We have potentially alerts from external observability sources or signals that some of your third-party SaaS or third-party providers are experiencing an outage, whether it's a cloud outage or service outage, right? That could clearly be affecting something within your four walls. And then lastly, how many users are being affected by this, right? Having signals from, high CPU is intellectually interesting, but knowing that high CPU has 4 or 5 customers who have already called in complaining about it, that changes the priority of this and the importance of this. So again, having the ability to understand and correlate the number of affected users within the service desk tickets is powerful as well. This is now the surface area of information that is bundled together and fed into our analysis AI to to do an impact assessment, a priority assessment, a root cause assessment, and then suggest actions for the human to take. So having these layers of concentric context, additional information makes that recommendation far more sophisticated and far more likely to get meaningful and useful next steps. Should we escalate? If we should, who should it be escalated to? Can we close this? Should we suppress this? Should we ignore this? How has this been treated in the past? All of those are, now at your operator's fingertips, having been automatically gathered and synthesized into very, very specific recommendations for the human to then decide how do they want to execute. Do they want to suppress it? Do they want to assign it? Or can they resolve it themselves? So by doing all that for them, taking a huge amount of that burden of manual IT operations or L1 operations off of their plate, and we think this is the way that we can dramatically start simplifying L1, and making it more effective, making it more efficient, making it more repeatable and mechanical and predictable, and really starting to try to address that 200 billion that we are collectively as an industry spending on L1. How can we reduce that green dollar spend? Can we get better outcomes with less spend in terms of approach? And we think automating a lot of this makes a lot of sense versus just throwing people at the problem, right? So automation clearly is a good way to start reducing that spend. Um, with that, I want to thank you. And ultimately, what do we have for the outcome? We have really, the end of this all is, three pieces. Be more accurate, be faster, and be more efficient. And higher rates of detection, happier customers, and be more collaborative between organizations rather than having teams either point the fingers or get on giant phone call, the bridge call from hell where there's 15 different people or 50 different people on them, right? So the more we can avoid those, the more we can automate and get the right data to the right people, the better everyone is going to be. So with that, I want to thank you, and I want to pass it back to Ellie.
Awesome. Well, thank you so much. Thank you to Russ for walking us through that overview of Big Panda agentic detection and response. And thank you to everyone here for joining our webinar. I want to note just in closing, because it looks like we are at time for this session. So with that, we will reach out to you directly if you submitted a question that we did not get to during this webinar. But if you are interested in learning more about AI detection and response, or furthermore, Big Panda as a whole, you can go ahead and please reach out to us. We'd love to talk more, dive deeper into the details of what Russ shared during his overview. And we will go ahead and get a demo scheduled for you. So please reach out if you have any more questions. And again, I would just like to thank you. Appreciate you joining us today, and we hope that you have a great day. Take care. Bye. Thanks.